All right. So, change of plans. Today's lesson is actually going to be just a quick review, reminding you that you do know how to evaluate a function. So, I want you to get out a piece of paper. That's what the directions in Canvas say. Get out a piece of paper, and you're going to write down some of these examples. Now, the graph that I'm sliding over to the right currently, that is not one of the examples on your breakout room. However, all of the other graphs that are in here, or all of the other functions that are in this video, are in your breakout room. So I'm going to start with the graph, reminding you what it means to evaluate a function, and then I'll jump into some of the sample problems. So the first thing that we have is a graph, and it says the graph below represents the function h of x. So now I want you to evaluate the function h of 1. This just means let x equal 1. So let's see what h of 1 looks like. So when x is 1, I follow my graph up and I am at this point right here. And this is the point, the y value of 6. So h of 1 equals 6. What if I evaluate h of 2.25? Well, that requires me to do a little bit of looking at the graph to see how each grid line is measured, or the numbers on them. So when I go across the bottom, I see that every other grid line is marked at a half, then 1, then 1.5. So that means that each individual grid line is a quarter, or 0.25. So 2.25 is actually this spot right here. So I'm going to follow it up till I hit the graph. And I see that I hit the graph here. I'm going to move back over to the left so I can see where I hit the y-axis. And h of 2.25 is actually 4. All right. Now let's look at h of 0.25. So that's the same thing as saying h of 1/4. When you let x equal 1/4. Well, when the value of x is 1/4, that's this right here. And that is also the same value as h of 2.25, which is 4. Okay. So all I'm doing is looking at a graph. Now, you guys have been doing this with functions for quite some time, and we've been actually doubling down on this by doing evaluating the function and then calculating the rate of change. So I'm not asking you to do average rate of change. Just find the x value, trace it up to the graph, and go over to where it hits the y-axis. Okay. So now let's look at a couple of examples from your activity today. So the first example has a equation. G of x is equal to 3x minus 12. And then the second item is a table, and it's labeled f of x. So example number 3 is asking me to evaluate g of 7. So I have to go to the g of x function. So the g of x function is 3x minus 12. Well, I'm going to get rid of that x. I'm going to replace that x with the number 7. So really, I have 3 times 7 minus 12. Well, 3 times 7 is 21, and 21 minus 12 is 9. So g of 7 equals 9. And that's answer number 3 for one of your questions on your functions breakout room. So let's look at f of negative 3. So this is question number 4. F of negative 3. Well, my f of x function is the table, and I just go to find x, negative 3, like when x is negative 3 on the table. And when x is negative 3, f of x, the output, is 31. So f of negative 3 equals 31. I don't even have to do any math. I'm just matching. All right. Question number 6 is interesting because it actually tells you that the output, f of x is your output, and it says f of x is negative 3. So I need to go to the table and find out when the output when my y value is going to equal -3. So the y value equals -3 when x is +3. It equals -3 when x is +3. Now, I specifically wanted to do an example like number 7 because this says this function is asking you to evaluate f of g of 6. So we kind of have to work like a parenthesis from the inside out. So we really have to evaluate this first. So I have to figure out what g of 6 is. So g of 6, well, my g of x function is 3x minus 12. So 3 times 6 minus 12. Well, that's going to give me 3 times 6 is 18. And 18 minus 12 is 6. So g of 6 has an answer of 6. So g of 6 has a value of 6. So f of g of 6, which is equal to 6, has me now evaluating at f of 6. So I know that g of 6 equals 6, so I just plug that into the f of x function. So f of 6 is, I'm going to go to my table. When x is 6, f of x is 5. So f of 6 is 5. So the answer for number 7, which is f of g of 6, well, that equals 5. F of g of 6 equals 5. All right, let's look at another one. So I specifically chose an example that has a word problem. F of x, my first function, is 2x squared plus 3. My second function, which is actually going to be called p of x, if you read that, I see a little p of x down here. It says Bob is a waiter who gets paid $7 per hour, x. If last night he made $25 in tips, find his total pay for the equation p of x. So p of x equals $7 per hour. That's 7x plus his tips, 25. So those are the two functions you're going to evaluate. So now question number 4 is saying, hey, I need you to figure out what p of 3 is. And from that, you're going to subtract f of -3. So let's find out what p of 3 is. That means I'm going to replace the x with a 3. So p of 3 equals 7 times 3 plus 25. So if Bob works for 3 hours, he's going to end up making 21 plus $25, which is pretty good money for a waiter. Most waiters don't make $7 an hour. But p of 3 is 46. So now we have to figure out what f of -3 is. So I'm going to subtract whatever f of -3 is. So let's figure out what that is. So the f function is 2 times -3, because I'm replacing that x with a -3, the quantity squared, plus 3. Well, order of operations says that I have to take care of exponents first. So I need to figure out what -3, the quantity squared, is. Well, -3 times -3 is 9. So I really have 2 times 9 plus 3. 2 times 9 is 18. Plus 3 is 21. All right. So let's look at what we're actually doing. I'm taking 46. That's what p of 3 is, minus f of -3, which is 21. Well, 46 minus 21 is 25. So answer number 4, p of 3 minus f of -3 equals 25. Question number 6, much like question number 4, asking you to work from the inside out. So I have to evaluate f of P of 1. So I have to figure out what P of 1 is first. So P of 1 is 7 times 1 plus 25. And 7 times 1 is 7. 7 plus 25, well, that's 32. So now I need to evaluate f of, so the whole function p of 1 equals 32. So now I'm evaluating f of 32. All right, so that's going to be a pretty big number because that's a square, right? So I need to take 2x squared plus 3. So 2x squared plus 3, but I'm replacing x with the number 32. So 2 times 32 squared plus 3. So let's see, what is 32 squared? Can you calculate that for me? Great. Grab your calculators. So 32 times 32 is 1,024. So I have 1,024 times 2, which is actually 2,048 plus 3. So my final answer is 2,051. So example 6 or question number 6, my final answer is 2,051. Now, I did that without a calculator. I did that with my brain. I didn't use a calculator. You could absolutely use a calculator. All right. Our last examples that I'm going to do for you, again, coming from your breakout room, are g of x and h of x. So this is interesting because I'm actually taking the function h and subtracting g from it and then evaluating it at 3. So let's look at what that means. My h function is negative 2x plus 3. And from that, I have to subtract the whole g function, which is x squared minus 1. Now you'll notice I have a negative out in front of this parenthesis. And the only way to get rid of that negative in front of the parenthesis and to eliminate the parenthesis is to distribute that. That's the same thing as multiplying by a negative 1. So let's do that. That gives me negative 2x plus 3. The first part of the function doesn't change. And negative 1 times x squared is negative x squared. And negative 1 times a negative 1 is a positive 1. So when I think about combining like terms, I cannot add anything to the negative x squared. So I'm going to put that first. So answer number 5, let's see. I have a negative x squared. And then the next term I'm going to do is the negative 2x. But I can combine my positive 3 and my positive 1. 3 plus 1 is actually 4. So the solution to the function h minus g is negative x squared minus 2x plus 4. Now I'm evaluating this at 3. I'm going to let x equal 3. So that gives me a negative times 3 squared minus 2 times 3 plus 4. So 3 squared is 9. Put your negative out in front of it. A negative 2 times 3 is a negative 6 plus 4. Negative 9 and negative 6 is negative 15 plus 4 equals negative 11. So the answer to question number 5, h minus g of 3 is negative 11. This equals negative 11. All right. Last one that I'm going to do for you, I'm going to do g minus h. So same exact thing that I just did, but now the g function comes first. So I have x squared, that's my g function, minus 1, minus the h function, which is negative 2x plus 3. So I have to take this negative that's outside of the parenthesis and I have to distribute it. So that gives me x squared minus x. A negative times a negative is a positive 2x. A negative times a positive is a negative 3. And now I'm just going to combine my like terms. Let's see, I have my x squared, my plus 2x, and then I have a negative 1 and a negative 3. And when I combine those, I get a negative 4. Now I'm going to let x equal 3. So I'm going to substitute 3 in for all of my x's. So that gives me 3 squared plus 2 times 3 minus 4. Well, 3 squared is 9, and 2 times 3 is 6, minus 4. 9 plus 6 is 15, minus 4 is positive 11. How interesting. So number 4, the function g minus h of 3 equals positive 11. So that is exactly how you are going to evaluate functions. You can work with your seatmate, but I'm not going to allow you to change seats or move around the room. Okay? Good luck.